Hello class, welcome to Unit 5, Video 5. Today we're going to look at adding probabilities. The learning target for today is that you can find the probability of inclusive events and mutually exclusive events. So let's go ahead and look at an example. To find the probability of spinning a purple and then spinning a blue, you need to find the probabilities of both events occurring separately. Spinning a purple and then spinning a blue are independent events because spinning one spinner has no effect on the other. Okay, so let's just go ahead and find the probability of getting a purple and the probability of getting a blue. Okay. So purple, if I look at it, it's not divided up very well, but let's just see, what would this be divided into? If I did this, looking at it, it looks like the purple, which is here, is approximately 1/6 of the spinner. And now if we look at the blue, this one's maybe a little bit easier to see. I could divide it into fourths, but how many blue are there? There are 3 out of 4 blue. Okay, and they're independent, like I said, because what happens on this spinner does not affect what happens on the other spinner. Okay, so mutually exclusive events. Okay, two events that cannot happen at the same time. They are exclusive. They cannot happen at the same time. If I said inclusive, they can happen at the same time. So we're looking at exclusive events. Here's examples. You can draw an ace or draw a 2 from a standard deck of cards. A card cannot be both an ace and a 2. Okay, so that's exclusive events. So we have looked at multiplying probabilities the day before. So whenever we saw that word and, that tells us to multiply. Okay, so if I want to know the probability of getting a purple and a blue, I would multiply them. So my probability of a purple is 1/6 times probability of a blue, which is 3/4. So for that one, I would get 3/24, which reduces to 1/8. Okay, so that would be my probability. However, today we're going to look at adding probabilities, and my key word for adding is or. Okay, so if I want to know the probability of a blue or a purple, it would be 1/6 plus 3/4. Okay, and remember to add, we have to have a common denominator. So my common denominator between 6 and 4 is 12. So I would multiply this by 2 and this by 3 to get to 12. So I have 2/12 plus 9/12. So when I add them, add the numerators, 2 plus 9, 11/12. Okay, so the probability of getting a purple or a blue is addition, and it's 11 out of 12. Okay, so probability of mutually exclusive events. Remember, exclusive means they cannot happen at the same time. The way it works is you take the probability of A or B is equal to the probability of A plus the probability of B. Biggest thing to remember, or means add. Okay, so let's go ahead and look at example 1. One teacher must be chosen to supervise a senior class fundraiser. There are 12 math teachers, 9 language arts teachers, 8 social studies teachers, and 10 science teachers. If a teacher is chosen at random, what is the probability that a teacher is either a language arts teacher or a social studies teacher? Okay, so what we're doing is we're trying to figure out the probability of language arts or a social studies teacher. Okay, so, well, I would first figure out how many total teachers are there. There's 12 plus 9 plus 8 plus 10. So adding that together, there's 39 total teachers. Okay, the probability of being a language arts teacher is 9 out of 39. Or, to be a social studies teacher, it's 8/39. This one's nice. I already have a common denominator, so I can just say 9 plus 8 is 17/39, and that is reduced all the way. If you wanted to leave it as a decimal and divide it on your calculator, it'd be 0.436, rounded to 3 decimal places. Okay, so that is example 1. Example 2, there are 7 girls and 6 boys on the junior class homecoming committee. A subcommittee of 4 people is being chosen at random to decide the theme for the class float. What is the probability that the subcommittee will have at least 2 girls? At least. Okay, this one gets a little bit more complicated because we are picking a group of people. So that means when we're picking a group or committee, that brings in our combinations. Okay, so first thing let's go ahead and do is figure out how many total people are we talking about. 7 plus 6, so there is 13 total people. We want to know the probability that the committee of 4 will have at least 2. So what I really need to do is figure out, well, the probability of having 2 girls, or the probability of having 3 girls, or the probability of having 4 girls. Okay, so got that or in there, so I have to figure out each one. Let's just figure out the probability of having 2 girls. Okay, if I want to have 2 girls, I am going to be looking at 7, and I'm selecting or choosing 2 of them. Okay, and we have boys on this one. So if I have 2 girls and I'm making a committee of 4 people, that means I have 2 boys. Okay, so then I have 6 boys and I am choosing 2 boys over my total ways to pick them is 6, so we had 13 total, and we are selecting a group of 4. Okay, that takes care of this first piece. Okay, so this is for this. Moving on to the next piece, or, so that's where I know my addition comes in. I'm going to write this all down here. Or, so I'm going to add 3 girls. Okay, if I have a committee of 4 and there's 3 girls, that means I'm going to have 1 boy. So to pick 3 girls, it's 7C3 times there's 6 boys, and I am selecting 1, over my total, which again is 13C4. Okay, so that is this piece. And we have to do or 4 girls. So plus, this time it's 7C4. And if there's 4 girls, that means there's 0 boys. So I really don't have to add it. But if you wanted to, you could do 6C20. Okay. Over my 13C4. Just a reminder, this means this is the number 1. Okay. So I would calculate all of these. On your calculator, if you do 7C2, and I would recommend checking it, but 7C2 is 21 times 6C2 is 15 over 13C4 is 715 plus 7C3 is 35 times 6C1 is 6 all over 715 plus 7C4 is 35 over times 1 over 715. 21 times 15 is 315. 35 times 6 is 210. So I would take 315 plus 210 plus 35, which gives me 560 over my 715. I would reduce that on my calculator. It's 112 over 143. And as a decimal, it would be 0.783. Okay, and there is example 2. So since we're picking those committees, we have to bring in combinations, and that at least 2 girls, that means I can have 2 or 3 or 4 girls. Okay, so that one is a bit tricky. If you have any questions on it, please let me know. So these were exclusive events. The reason this one is exclusive is because you're either a boy or a girl. It can't be both. Okay. This one, it's or, because you're either a language arts teacher or you're a social studies teacher. You're not both. Okay. So inclusive, that brings us to, is there are 2 events that can happen at the same time. Okay. So here's an example. Drawing a king or a spade from a deck of cards. Well, you can be the king of spades, so they are inclusive. Okay, so the way that this one works is it's still an or statement. Okay, so we still use addition. Okay, but the thing that's different is if they can both happen at the same time, you subtract when they both happen. So I like to call it the probability of both. Okay, so you add them together, subtract the probability that they both happen at the same time. Okay, so example 3. Suppose that of 1,400 students, 550 take Spanish, 700 take biology, and 400 take both Spanish and biology. What is the probability that a student selected at random takes Spanish or biology? Okay, well, what we have to do is we have to figure out the probability of Spanish plus the probability of biology. And then we need to subtract the probability of being both. Okay, so probability that you take Spanish. 550 out of 1,400 plus to take biology 700 out of 1,400 minus the people that do both, 400 over 1,400. So I would add up 550 plus 700 minus 400, and I am left with 850 over 1,400. I reduce that, and I get 17 over 28, or as a decimal, it's 0.607. That is example 3. Example 4. There are 2,400 subscribers to an internet service provider. Of these, 1,200 own brand A computers, 500 own brand B, and 100 own both. What is the probability that a subscriber selected at random owns either brand A or brand B? Okay, so probability of brand A plus probability of brand B, but we have to remember to subtract the double, so probability of both happening, okay, A and B. So to be A, there's 1,200 over the 2,400 plus B, 500 over the 2,400 minus both, 100 people own both. So 1,200 plus 500, 1,700 minus 100 is 1,600 over 2,400. And then just remember your little tricks, the zeros will cancel. So I really have 16 over 24, which reduces to 2 over 3, or 0.6 repeating. So there is example 4. Now we have some mixed practice. So we have 4 problems, okay, and you need to decide, are they independent, dependent, mutually exclusive, or inclusive? So A, what is the probability of drawing a jack or a spade? Okay, or, so probability of a jack or a spade. So remember, a spade is like a shovel. Okay, so what's the probability of being a jack? Well, there are 4 jacks, and they're right here on my card, so it's 4 out of 52. Plus being a spade. So spade is a suit, so there's 13 out of 52. And then I would ask myself, can I be both? Can I be both the jack of spade? Yes, there's 1. So I would minus 1 out of 52. So this one is an example of inclusive. They are included. So 4 plus 13 is 17 minus 1 gives me 16 over 52, which is reducible. So it's 4 out of 13, or 0.308. Okay, there's an example of inclusive, because you can be the jack of spades. You need to subtract the jack of spades. Looking at B. All right, what is the probability of drawing a queen and then a jack? Okay, so this one is an and statement, so we want a queen and a jack. Okay, so that means multiply. If the first card is not replaced before drawing the second. Okay, if it's not replaced, that means it's dependent. Okay, so I know to be a queen, those are right here. So to be a queen, it's 4 out of 52 times, because it's an and. Then I'm hanging on to my queen. How many jacks are there? These are the jacks, so there's 4, and there's only 51 cards left now. So if I go ahead and multiply this one, I get 16 over 2,652, which reduces to 4 over 663. And as a decimal, it's 0.006. Okay, so there is our answer for B. So this one is dependent, and it's an and statement, so we multiply. C, what is the probability of drawing a 2 or a king? Okay, so I know it's probability of a 2 or a king. So I know I'm going to be adding. To be a 2, right here, there's 4 out of 52. Plus, because it's an or, a king, there's 4 out of 52. And then you ask yourself, can I be a 2 of king? No, you cannot, so that makes it exclusive. You cannot be the same thing. So 4 plus 4 gives me 8 out of 52, which reduces to 2 out of 13, or 0.154. Okay, so that is an example C. Example D. What is the probability of drawing a face card and then an ace? So I see the word and, so I wanted the probability of a face card and then an ace. Okay, face cards are anything that have a face on them. So here are my face cards: Jack, Queen, and King, but there's 4 suits. So there's actually 12 out of 52. Times, now the first card is replaced before drawing the second. So that tells me it's independent. What happens on this next try will not be affected, so I know it's out of 52. And an ace. How many aces are there? There are 4. So I multiply this one. I get 48 out of 2,704, which reduces to 3 over 169, or 0.018. And that is my answer for D. Okay. So in our mixed practice, we had both adding and multiplying like yesterday. So just to recap, this one is what we went over today. So or means adding. It's inclusive because you can be the Jack of Spades right here. So it's inclusive. C was our other or one. It is exclusive because you can't be a 2 and a king. Okay. And so those are what we covered today, being inclusive and exclusive. And then yesterday we talked about being an and statement and how you multiply, and then if you're dependent or independent. This one is dependent because the card was not replaced. Part D was independent because the card is replaced. And what happens on my second draw is not affected by what happened on the first draw. Okay, so that mixed practice is a nice way to kind of distinguish the differences between what we covered today and what we covered yesterday. If you have any questions on probability, please let me know. Otherwise, go ahead and you can do that Unit 5, Practice 5, and have a great day.